Okay, absolute value equations and inequalities. A compound statement can be made up of more than one equation or inequality. A disjunction is a compound statement that uses the word or. Right? So we've graphed a lot of stuff on number lines when we've solved inequalities. And so we're going to do that again today, except we're going to be looking at more than one situation. So if you have the word or, it's a disjunction, which means that the arrows are going to go opposite directions as they show here. So it would look like, x is less than or equal to -3, or x is greater than 2. The disjunction is true if and only if at least one of its parts are true. So it may be only one of the parts. It may not be both. A conjunction is where the word and is used, and that's where they're going to go together. So you have two dots connected by a segment. And so here you can see this little reading of math here. It says a dis means apart. So disjunctions have two separate pieces. And con means together, so conjunctions represent just one piece. Okay? So if it's or, there's going to be two pieces. If it's and, there's only going to be one piece. When you write the statements with and, you can either write it as like this: x is greater than or equal to -3 and x is less than 2. Or this is the way you should write it. Put x in the middle. Then it shows greater than -3 and less than 2.
So we're supposed to write it.
Right? Yep, this is yep. You're writing it this way. Now, if it's or, you have to put the word or in there. You can't put them together as one thing like this. This only works for and. Okay? So disjunctions use or, conjunctions use and. Okay? So we're going to solve each of these compound inequalities, and then we're going to graph them on a number line. So letter A says 6y is less than -24, or y plus 5 is greater than 3. So we're going to solve both the inequalities, and then we're going to put our answers on a number line. So we divide 6. Y is less than -4, or subtract 5. Y is greater than or equal to -2. So when we graph them on the number line, we will have an open dot on -4 and a closed dot on -2. And then our graph at -4 is going to go to the left, and at -2 is going to go to the right. Okay. And because this is then a disjunction, because of the or, then that means we have two separate pieces, as we do here. Letter B. Here we have another situation where we have two inequalities and separated by the word and. So what does that tell you about what the graph's going to look like? Okay, they're going to come together then. Okay. So we've got 1/2 c is greater than or equal to -2, and 2c plus 1 is less than 1. All right, so how do I solve this one on the left? What do I do? Okay, right, we're going to multiply by the reciprocal. So because it's 1/2 times c, we're going to multiply both sides by 2. So c is greater than or equal to -4. And with the other one, we'll subtract 1 from both sides and divide by 2. So c is less than 0. So we've got closed dot at -4, and an open dot at 0 because it's just less than. And from -4 it says greater than that, so that means I'm going to the right. From 0 it says less than, so I'm going to the left. So we're just going to connect them. Now make sure, one of the things I've seen some of you do is that you put your dots above the line or below the line, okay? Put them right on the number line. Okay? Don't put them above the number line. All right, so I don't want to see this. Okay, that's not appropriate. Okay, it's supposed to go right on the number line, so make sure you're putting them right on the number line. Okay, so we add 5, x is less than 3, or, which means we're going to have two parts, and then divide by -2, so x is greater than or equal to 5. Make sure you remember that when you're dividing by or multiplying by a negative, you have to change the direction of the inequality. So open dot on 3, closed dot on 5. So your graph should look like that. Okay. Absolute values. What does absolute value mean? Anybody know? Spencer? Okay, so it's going to be positive, okay? And there's a reason for that. It's because absolute value is the distance a number is from 0, okay? And whenever you talk about distances, it always has to be positive. So here they show, right, absolute value of x equals 3. So it could be -3 or +3. If the absolute value of x is less than 3, that would be all the numbers from -3 to 3. And so that would be a conjunction, okay, where the word and is used. And all the numbers that are where the absolute value of x is greater than 3 are the numbers that are outside the 3's. 4, 5, 6, -4, 5, 6. Okay? Because if we took the absolute value of -4, that's 4, and which should be greater than 3. Okay? So we can, this thought process here for this helpful hint, we're actually going to use this a couple times in this chapter, and then we're also, as we finish this chapter, but also in chapter 5, it says to think great or inequalities involving greater or greater than or equal symbols are disjunctions. Notice the blue highlighted there. Think less than inequalities involving less than or equal symbols are conjunctions. Okay? So you can think of it that way. If they say greater or, okay, it's a disjunction. Less than, it's a conjunction. So absolute value inequalities. So we have this general statement then. Absolute value of x equals a. So x could be -a or a. If it's absolute value of x is less than a, then it's going to be x is greater than -a, less than a. And absolute value of x is greater than a. X is less than -a or x is greater than a. And those cases will always be true. All right, so we're going to solve some equations and some inequalities using absolute value. So it wants to solve this equation. So the absolute value of -3 plus k equals 10. This can be read as the distance from k to -3 is 10. So now, what does this mean then to solve this? Well, -3 plus k equals 10, or -3 plus k equals what? negative 10. Yep. Two different equations. So negative 3 plus k could be a positive number 10, okay? Because what's inside the absolute value could be positive or negative. And so you have to take both of those into account when you're solving the equations or inequalities. So you're going to end up with two answers all the time. Okay? There's always going to be two answers. And they're not necessarily both going to be positive or negative, depends on the equation or the inequality. Okay? But you are going to have two different answers. Okay, when it just says equal to, you don't have to graph them. We're going to do inequalities in a minute. Those will graph on the number line. But when it says equal to, you don't have to graph them. But if I did graph them, what would I have? Yeah, you would just have two dots on, is all you would have on the number line. Okay. Now, this right here is very important that you understand that. If there's more than just the absolute value on the one side of the equal sign, the first thing you always want to do is isolate it. So it's kind of like if we had a problem that looked like this. Okay, what would I do to solve that problem? Subtract 6, okay? And we're doing the same type of thing, is that the whole point here is to isolate the x. So you can think of the absolute value symbol and everything that's inside of it as like an x that I want to get by itself. So anything that's not inside the absolute value, I want to move to the other side before I solve. So in this case here, we're going to add 6 first of all. So we get the absolute value of x divided by 4 equals 4. That's always got to be the first step. If you have anything else, anything multiplied by it, anything added to it, those things have to go to the other side first of all, so that all you have left on the left-hand side is absolute value. Now, x over 4 could equal 4, or it could equal negative 4. You can't do the equals negative 2 and equals positive 2 at the start. You've got to do that first. Because, first of all, when does an absolute value equal a negative? Never, right? Because it's always positive. It's a distance. So if I had just absolute value of x here and just a negative number over here, that would never be true anyway, so there would be no solution to that. So you've got to make sure that you isolate the absolute value first. So this is a situation where I get the positive and the negative of a number, but it doesn't always happen that way. And so don't assume that it's always going to happen that way. Okay? All right? But you have to isolate the absolute value first. Okay. Solving absolute value inequalities. The first thing we're going to do is we will isolate the absolute value. Then, if necessary, rewrite the absolute value expression as a compound inequality, and then solve each part. Now, there's one trick about this when you're doing the absolute value. When we go from the positive to the negative, we are going to change the direction of the inequality sign. Okay. So when we rewrite this, we will have negative 4q plus 2 is greater than or equal to 10. So when I just drop the absolute value and write that, I write exactly as it is. When I go to do the negative, I'm going to change the direction of the inequality sign then. Okay. Now notice, this says absolute value of negative 4q plus 2 is great or than 10, which means when I get my final answer, it's going to be a disjunction, and my arrow should go the opposite way. Okay? So we're talking about or here. So we solve the inequalities. Add 2 or subtract 2. Negative 4q is greater than or equal to 8. Divide by negative 4. Q is less than or equal to negative 2. Make sure you remember to change the direction of the inequality sign when you divide or multiply by a negative. Subtract 2 on the other part. Negative 4q is less than or equal to negative 12. Divide by negative 4. And q is greater than or equal to 3. So in both these cases, we have or equal to, which means that we're going to have solid dots at negative 2 and at positive 3. And since it says or, then we're going to go away to the left, to the right. Great or, then 3, less than negative 2. All right, so the big thing is when we switch the direction of the inequality sign, or when we change it to negative, you got to remember to switch the direction of the inequality sign to start with. Okay, so that's the biggest part there. Letter B. Absolute value of 0.5 r minus 3 is greater than or equal to negative 3. So our first step is going to be to isolate the absolute value. So the first thing we're going to do is add 3 to both sides. So we get the absolute value of 0.5 r is greater than or equal to 0. All right, so I want you to think for a second. Okay. When is absolute value greater than or equal to 0? Okay. All right, so let's, all right, so now, when we find the absolute value of something, it's always going to be what? Positive, correct? Okay. How many positive numbers are greater than or equal to 0?
Billions.
Okay. Infinity or all of them, right? Okay. So the answer to this is going to be, so if I did this, I'd say 0.5 r is greater than or equal to 0, or 0.5 r is less than or equal to negative 0, which is still 0, isn't it? Okay. So this would say, so if I divided by 0.5, I would get r is greater than or equal to 0, right? And, oops, this is an and, not an or. Or no, it is or, sorry. Okay. Or 0.5 divided by 0.5 over here, and again, it's less than or equal to 0. What numbers is that? That's everything, right? Okay. So if I did this, basically, here's what I'm saying, is that here's 0, it's a solid dot, and my arrow is going to go both directions. Oops. And down. Yep. And down. So it would be all real numbers would be my answer to this. All real numbers. That's always true. Okay? We're going to look at it with and. Okay? So we just solved the inequalities using great or, so we had disjunctions. Now we're going to look at them with conjunctions. And remember that the first thing we always want to do is isolate the absolute value if necessary. So here we have the absolute value of 2x plus 7 divided by 3 is less than or equal to 1. Okay? Since it's less than or equal to, it's going to be a conjunction. It's going to be less than. And so is the 3 inside the absolute value or outside it? Okay, it's outside it. Since it's outside the absolute value, I need to get rid of that first. So we need to multiply both sides by 3 first of all. So we get absolute value of 2x plus 7 is less than or equal to 3. Now, since we have a positive number here with the 3, then I'm going to do 2x plus 7 is less than or equal to 3, and 2x plus 7 is greater than or equal to negative 3. And this is going to be and because it's a conjunction. All right, which means that both things have to be true for the answer to work. So we subtract 7. So when I write my answer for this one, okay, I'm going to write it as a, before I graph it, I'm going to write it as a single, okay, compound inequality, which means I'm going to put x is greater than or equal to negative 5 and less than or equal to negative 2. This would be the correct way to write the compound inequality. Put x in the middle, greater than or equal to negative 5, less than or equal to negative 2. So we have open dots on, or closed dots on negative 5 and negative 2, and fill in between them. All right, so let's look at one more. Okay. Now, this one says negative 1/2 times the absolute value of p minus 2 is greater than or equal to 3. Okay. Now, the first step we're going to do is what? Okay, we need to get rid of the negative 1/2 because it's outside of the absolute value. So we're going to multiply by the reciprocal, negative 2. So we get the absolute value of p minus 2 is less than or equal to negative 6. Now, here we go. We talked about this. There's a negative number here. Okay? So either my answer is going to be everything or nothing. Okay? So take out your calculator and graph it. Let's see if it's everything or nothing. Y equals x minus 2. Absolute value of x minus 2. And then I'm going to go ahead and put negative 6 in y2. And we want to know, when is the absolute value less than negative 6? Well, what do we know about absolute value? It's always positive. So if I graph them, when is the absolute value less than or equal to negative 6? Never. So your answer then is going to be no. That right there. Anybody know what that right there is? That is the empty set, or you could say that there is no solution.
Can we just write no solution?
Okay, yes, you could write no solution. Okay?